Welcome back. Now that we've learned a little bit about control structures, I wanted to walk through a couple different, slightly more advanced programming examples with them. First one refers to sorting a series of values here, and there are numerous different ways of sorting a set of values, and we'll apply a relatively straightforward approach. But from there, we can learn more advanced approaches later on in the course. So the problem has an input with five integer values provided in any order. The output is a printout of the five input values sorted in ascending order. So when we refer to something being sorted, we usually have to also specify sorted as to what. In this case, if they're integer values sorted in ascending order, the first value should be the smallest, the last value should be the largest, and everything else in between should be in order. And I provide a hint. As on many of the programming practices, I provide a hint. If I provide a hint, you probably should use the hint, and in this case, we should use it. If we use a temporary variable, in this case called temp, we can easily quote unquote swap to other variable values. If you look at that small piece of C code there, we have var1 is 7, var2 is 5. We have a temp. We store temp as var1. We store var2, overwrite with var1, overwrite it with var2. var2 then becomes temp. That has swapped the value of variable 1 and variable 2. We started with variable 1 is 7, variable 2 is 5. When we're done, variable 1 is 5, variable 2 is 7. That's what I mean by a swap operation. So we have the problem, we have a little bit of a helper code, and obviously we should just dive in and get started coding. Wrong. Let's go to pencil and paper or digital whiteboard in this case, and let's think a little bit about what it would mean to actually do this sorting operation. So I'm not going to rewrite the input and output specification here, but we know we're going to have a series of values. And I think it's always okay to start with an example as opposed to something more kind of formal. So for our example, we're going to have five values. It doesn't really matter what they are other than we want something that actually would require some sorting. We'll say 21, 7, 8, 3, and 16. That would be our input that we would have here. We know what the output would want to be in this case. We would want it to be 3, 7, 8, 16, 21. And I mentioned as a pretty strong hint that we can swap two values. So there's a three-line piece of code that would allow us to swap, variable 1 and variable 2. And just for brevity, we're going to call that v1 and v2 and the rest that we have here. We can call it variable 1 and variable 2 in our actual C code where we don't have to write as much. We know we can swap. So there is that kind of switching this one and this one operation that we know now, or at least we have a little bit of a code template that allows us to do it. Doesn't exactly answer the question, but it partially answers the question of, what do we need to do to actually get this from unsorted to sorted in ascending order? Well, at the very least, if it was just two values and I wanted to make sure they were in correct ascending order, we would just need to do a single swap. And we would do that single swap. Well, when would we do that single swap? What would be the condition that would cause that to happen? Or that would require that to happen? Well, we want it in ascending order. If it's not already in ascending order, we should do that swap. We don't have to be as syntactically correct if we were writing the C code, but something along the lines of, well, if V1 is greater than V2, we should in fact swap those two values. Okay, that sorts two values. We need to sort five values. After we've done so, we have the value of our variables. There's 7, there's 21. We still have the other ones in their original positions. What can we do next? Maybe you're seeing where this is going here. Well, we can look at 21 and 18. In this case, not the hard-coded values, but we're looking at V2 and V3. Same scenario would happen. V2 is in fact greater than V3. And we'd want to wind up with 8 and 21 there, with the other variables not necessarily changing. Continuing on, that's two values now that are at least relatively in order, although we got a little lucky that 7 happens to be less than 8 and those appear to be in order. We haven't compared 7 via 8. We can keep going. We have now this variable v3. We can compare it against v4 and do the same. We now have 21, v4, and 16 as our v5, and we can do that sorting as well. That swapping as well. Let's move this so we have a little bit more space to work here. If this was v2 greater than 3, this is v3, so it's be a 3 greater than v4. This is then v4 is in fact greater than v5. And we wind up with not a sorted array, although it's getting there, right? But at least a set of values in which we have some promise that the largest value is going to make its way all the way down. We've compared each value against its neighboring value in kind, and we're swapping if it's larger than the one next to it. So by the end of doing that, we wind up having at least a couple of values, or in this case, we're guaranteed to have that one value of 21 if it's the largest in the right location. And in fact, we don't actually need to look at this one anymore. We've compared it to all the other values, and we've wound up with whatever was the largest one is going to be in that spot again. We can actually then just sort of repeat the process. I'm just going to draw an arrow, although we haven't learned about iteration structures that we could loop. In our case, we won't use a loop. We'll just kind of repeat the code that we previously had for that. We could then look at the next 4 values and do the same thing again. Compare 7 versus 8. Well, we don't need to swap in that case. Then compare 8 versus 3. We do need to swap. Then compare 8 versus 16. We don't have to swap. We now have the second to most largest number in the right location. We've continued to partially sort. We would then do it for the first 3, and then finally for the first 2. We really don't have to do it for a single element by itself. So for 5 values, we have this kind of iterative process with a relatively simple if statement, just repeated multiple times, that allows us to get from an unsorted list of 5 random values to a set that is sorted. I mentioned there are many, many different ways of sorting numbers. This is a very well-known, not super optimized, but that was never our goal, type of sorting algorithm referred to as bubble sort. So if somebody asks you to implement bubble sort, this is essentially what they're asking you to do. Compare each element pairwise and go in turn. Each time you do that through the set of elements, you've sorted one of those values. You have to do it if there's n values, n minus 1 times to actually get the final result back out. Let's actually do that in our code then. It is helpful to have that piece of paper or whiteboard nearby as you're working on this. Here we have just pretty brief notes here that are just how we actually do the swap in RC, and nothing else is provided for you, but we can kind of go based on our knowledge of how do we grab input values, how do we do comparisons, and we can kind of just build up the code with maybe a little bit of copy and paste helping us along the way. As always, let's do a prompt. Let's say enter in 5 values. Enter in 5 values separated by commas. Then we can do a single scanf statement. We would want to put the commas in the scanf statement in that case. The scanf would then look for an integer. When it finds one, put it in a var1. It would look for a comma. It would then match the comma, move on, find the next integer, look for a comma, find the next integer, etc. We don't have to have 5 scanf statements here to read in 5 variables. At some point it gets cumbersome, but this isn't too bad. We can keep track of 5 in a single statement. There's our 5 values we're going to read. I always like, just as a sanity check if nothing else, okay, I think I've done the prompt and the scanf correctly. I should just really quickly confirm that, I've actually read in the values I think I've read. If you didn't get the right values on your scanf call, well, the rest of your code's not going to work. Let's just have a quick confirmation that, yes, you think you read in these values. Did I actually read in the values I thought I did? It can become a little cumbersome depending on the amount of data you're inputting, but for 5 values, we can do it. So I'll say before our sorting, our values are the following, and it should look roughly the same as your scanf statement, although we're printing, so we can format it a little bit nicer and not have to type in anything for that. We have the 5% D format strings here. That should then, I don't remember the exact numbers. That's good enough for testing. And it hasn't done anything yet, but hey, at least it printed out. I did my scanf correctly. Moving on to the next stage. We've read in my input. I'd like to think at some point we'll actually get it sorted. So hey, let's add an extra one at the end here. We'll just say after sorting. Okay. Going back to our little virtual dry erase board here, what did we do? We did a comparison of V1 and V2. If V1 was greater than V2, we would want to swap V1 and V2. This is just kind of visualizing the swap, but we have what the template C code should be to actually do the swap for us here. Let's actually do that. I don't know if this would require a comment or not, but we want to check, hey, if var1 is greater than var2, we want to exchange them. We want to swap the two values that we would have there. That template is exactly listed here. Temp equals var1. var1 is then overwritten with the old var2 value. And var2 is now the value we stored for our temp. We actually do need a temp integer declared, otherwise it can be pretty unhappy when we try to do that, but that should swap those first two values. That doesn't sort it, but that's at least the first stage. Let's enter in those values again. And we don't have a fully sorted, but we've sorted those first two elements. 21 was before 7, now 21 is after 7. Now we can start to think about a little bit of copy and paste, right? We did var1 versus var2. Now we got to do var2 versus var3. You can type, and there's a trade-off depending on how precise of a typer you are versus how good you are at copy pasting and changing what needs to be changed. Either approach leads to bugs. There's not one approach that's better than the other. I like to copy and paste if I know it's similar enough, and then I just have to inspect. Okay, the first block of code compared var1 versus var2. And let's add a comment. Is var1 greater than var2? We should swap them. That's a reasonable comment. Then consequently, this code is not the same. This code would now be, is var2 greater than var3? If so, we should swap them. That's what the comment says. That's not what the logic's doing. Let's say you get interrupted in between writing that comment and writing this code. Well, then you should be able to look at the comment and say, oh, my code's not correct. I'm actually not doing what the comment says, but now we are. If var2 is greater than var3, swap var2 and var3. And the same for var3 and var4. It's a little cumbersome, but when we get this part working, it won't be too bad at that point. And then finally, we do so for var4 and var5. And we do know at that point that var5 at least is in the right place. We can confirm that via just another test, that 21 got put where it was supposed to go. And there we have it. 21 is the final element. We have partially sorted those set of values. I would write a comment something like, at this point, var5 is sorted, or it's done. It's in the right location. We don't have to look at var5 anymore. Going back to our digital whiteboard here, we do have to look at the other ones. So I didn't quite show it, but what it's showing here is we do the first 5, 21's kind of locked in place, or whatever the largest value is. We now need to go back and actually look at the first 4 again. That is a little cumbersome, but the nice thing about it is we've already got the code that does exactly that. And here I'm not changing it. It's literally doing the same exact steps again. We should now have, although it's not going to look that different based on what I entered. Let's put 16 earlier for that reason. Now we should have 16 and 21 are now in the right locations. Before 16 was already in the right location, it wouldn't have looked any different. Making some progress here. I don't know if we have to overdo it, but we do have that comment. At this point, var4 is sorted. Let's copy that entire block. Now we need to do 1, 2, and 3. We don't need this last comparison. It wouldn't hurt to have it. It wouldn't be wrong to continue to compare, but they're already in the right order. We wouldn't need to do that. Let's enter in 21, 16, 7, 8, 3, and we're getting there, right? The last 3 values are in the right location. At this point, var2, and I would say and var1. If var2 is in the right place, then var1 must be in the right place. And we really only at that point then need to compare variable 1 versus variable 2. Let's do some numbers that are in guaranteed opposite order. That's kind of the extreme case for our sort algorithm. And we had 99 through 95, and when we're done, we have 95 through 99. Couple takeaways from this example. I want you to really think about the problem you're trying to solve before you dive into the code. I've said that enough. I won't say it again this semester. But that helped, I think. By visualizing what we wanted to do with the data, the C syntax was a little cumbersome. I mean, hey, this is probably our longest program, right? We've written over 100 lines of code, even though some of it was copy paste. And being given the hint of here's how you may want to swap two values, we can now sort those five values. If we wanted to sort 100 values, the code would be really cumbersome, but you could do it using this, right? It's just more copy paste. Likelihood for bugs kind of increases as you're copying and pasting that much, but conceptually at least you would be able to do that. We'll learn some more powerful tools to sort larger and larger arrays of data eventually here. The other thing, a takeaway is, start with data input, confirming data input, adding those printf debugging statements. It would have been equally valid to kind of add an extra printf at every step of the way, just to debug that, yeah, after each stage I'm getting values that I think are correct. We kind of scaffolded it up bit by bit anyway, so it worked okay with had the printf at the very end. But don't be afraid of extra debugging. Even if the programming practice specification says print out only this value at the end, yeah, at the end that's all your code is supposed to do and nothing else. But along the way, print out all the things you may need to understand what's happening, why parts aren't working the way you would expect them to. It's always easier to just get rid of a printf after the fact versus not having that information there to help you debug as you're going. Printf liberally, inspect your data, don't assume, verify, and I think you'll have a better time with coding. Let's do one more coding practice that arguably is a little bit easier, but it's just a different construct we would be using for this. So another problem-solving exercise is if we have an input that is an integer representing a day of the week, so values of 1 through 7. I would want the output to be just a printout if the day corresponds to a weekday or a weekend. So, for example, if the input was 5, that would correspond to a Thursday, and we would print out today is a weekday. If the input was 1 or 7, that would correspond to Sunday or Saturday. I'd want the printout to be today is the weekend. If it's not in that range, we should do a little bit of range checking, which we haven't done a lot in our code. But in this case, if it's not a value in the range 1 to 7, we should output invalid day if that's the case. There's two different ways we could solve this problem. Actually, there's multiple different ways. But based on what we've learned about control structures, this may in fact make sense to apply a switch statement to. Sounds like a switch statement kind of problem. There's 7 discrete values we're interested in. Everything else is invalid. But we can also use our if statements, either via simple if statements or more complex if statements to solve this problem. I'm going to devise a solution here. I don't think we have to necessarily whiteboard this one. And it may not be the same exact solution you would come up with, because depending on whether we use Boolean operators or chained if statements, you can get the same exact result just via different coding mechanisms. This is example weekday on our Replit page here. And as before, we kind of have to read in some values when we begin here. So we're going to need to have some value corresponding to the day. And our prompt, as always. When you get a README that's telling you to have some specification, just copy and paste what the README says, and that can be your printf code. Enter in an integer in the range 1 through 7. There's our scanf following. A little bit easier than the scanf for the previous example. Again, there's not one way to do it. If the day is 1 or if the day is 7, it's the weekend. If the day is 2 through 6, it is a weekday. If it's anything else, it's an invalid day. There is no right order of operations there. Do we look for weekend first? Do we look for weekday first? Do we look for invalid day first? There's no right or wrong answer to that. Your code will look different depending on which one you chose, but they're all appropriate. Oftentimes, although it wouldn't be the case here, we really want to be done with our code if we have invalid input. Okay, the input's invalid. If I continue on, something bad may happen. There's a reason I'm declaring that invalid input. In this case, nothing bad would happen necessarily. We're only printing out stuff. But I think it's reasonable to check for the invalid cases first. Okay, so if the day is not between that range 1 through 7, it's invalid. A lot of different ways we can encode that. The less than operator and greater than operators is certainly one way to do it. So certainly, if our day is less than 1, we should certainly printf invalid day or whatever the spec said. Again, if you're unsure of the spec, it should be in a README for the programming practice. Just copy paste what it says to print out. If day is less than 1, invalid, invalid day. We could also have if day is greater than 7, same. Printf invalid day. But we then also have those Boolean operators, right? If day is less than 1 or day is greater than 7, it's an invalid day. You didn't have to do it this way. The two if statements would have also been fine, but logically, that's I think a reasonable way to encode that. Likewise, that's if that happened. Else, we didn't have the invalid day, but we have another if we're interested in. If our day is equal to 1 or our day is equal to 7, what did it say to print out? Today is the weekend. Fair enough. With a capital for some reason. Finally, well, it's if, that's our left-hand side, invalid. Else, it's our whole right-hand side of our control flow graph. I know my hands are backwards in the video. Else, if the day is 1 this. Well, if that's not true, then anything else is our final branch of that logic. You could also do a separate if you want to be clear that you're checking for 2 through 6, but you actually don't need to. It would have been fine if you had added an extra if statement there, but left-hand branch, 1 or 7. Right-hand branch, not 1 or 7. Left-hand sub-branch, 1, 7. Everything else is weekday. I think we'll be okay. We can test this quickly. 3, weekday. 1, weekend. 7, weekend. Negative 124, invalid day. We should probably test a little bit more thoroughly than that, but I feel pretty confident this is working. That is approach 1 to solving a problem. Totally valid. Unless the question somehow says you must use a switch statement, you don't have to use a switch statement. But I would say that this problem also suits itself to a switch statement because we know there's just a few values we're interested in. And of course, I wanted to show the switch statement in practice. The keyword is switch. Switch on a single integer value, in our case, day. And we have a number of cases. We don't need that much space here. A number of cases we're interested in. Here, we should probably think of the valid cases and then worry about the invalid cases as our default. If it's a 1, we would printf the same as before. I should, just copy paste that versus trying to reinvent it here. Today is the weekend. We add that break keyword. Hey, it was 1. We printed what we wanted to print. Let's get out of this switch statement. Same for case 7. Today is also the weekend. But kind of like how we saw before with that if statement where we decided it's kind of if or, we can do the same thing with our switch statement, which is if we know that what we want to do for the case of 1 is the same what we want to do for when the case is 7, you can actually combine them together. You can put code in between them as well, but what that would do is when we matched for 1, it would continue on down. It actually doesn't do anything for case equals 1, it would just continue on down. For 1 or 7, it would in fact print today is the weekend. That'll simplify our code a little bit for the other cases as well, right? That's case 2, case 3, case 4. So is this easier than the if statement? Well, probably not, but depending on what else we want to do, I think this is a reasonable approach to it. That is our weekday case. Today's a weekday. And now the nice thing really I think about the switch statement is for everything else that may happen, well, it wasn't 1, 2, or 1, 7, 2, 3, 4, or 6. Now we're at our invalid day in our switch statement. Default, invalid can sometimes mean the same thing. Other times we do have a default case that we want to actually print. Today is not a day in the range 1 through 7 or something. It doesn't mean it's necessarily bad, but it's a pretty good catch-all for things that you weren't necessarily expecting to be inputs to your code here. Let's run it again. This is with the switch. 1 is a weekend, 7 is a weekend, 3 is a weekday, and what was it, negative 142 is an invalid day. These two code blocks are identical in terms of functionality. One is not better than the other. I would hesitate to make any kind of value judgment about one version of the code versus another version of code. Whichever one you can explain, whichever one you can write, whichever one you can debug is the right way to solve this problem. If you have a discrete set of values, switch statements make a lot of sense. Again, as I mentioned in the last video, I don't know what that upper limit is. Is it 10 cases? Is it 15 cases? Is it 100? I don't know. At some point, you should be thinking then of, instead of discrete values, thinking in terms of range values, and then it gets a little bit easier to encode it with if statements, even chained ones, versus using our switch statements. Let's leave things here for now. Best of luck with programming practice 3. Let me know where you get stuck. The complexity is supposed to be roughly the same complexity of what we just covered in these two examples, and I absolutely know you can do it. But when you get stuck, reach out for help. Really happy to help you with those.